We say this out loud as primary, not as first degree. We don't call it a first degree carbon, we call it a primary carbon. The degree of substitution of a carbon atom is the number of other carbon atoms to which that carbon atom is attached. So we consider a carbon atom and we count up the number of other carbon atoms to which it's attached, and that tells us the degree of substitution of that carbon atom. We can have different kinds of degrees of substitution. The least substituted kind of carbon would be a methyl carbon. That would be a carbon that's attached to 0 other carbon. We can have a primary carbon. This primary carbon is a carbon that's attached to only 1 other carbon. One note, we say this out loud as primary, not as first degree. We don't call it a first degree carbon, we call it a primary carbon. Don't say first degree, just say primary. We could have a secondary carbon. That would be a carbon attached to 2 other carbons. A tertiary carbon would be attached to 3 other carbons, and a quaternary carbon would be attached to 4 other carbons. Let's look at this molecule here and see if we can start to identify the degree of substitution of some of these carbon atoms. We'll start on the left side. This carbon atom on the end has 3 hydrogens attached and is attached to 1 other carbon. That makes this carbon a primary carbon. This carbon would also be primary for the same reason. This carbon is only attached to 1 other carbon. This carbon here has 1 hydrogen attached and is attached to 1, 2, 3 other carbons. That makes this one a tertiary carbon. This carbon is attached to 4 other carbons. This is a quaternary carbon. This carbon up here would be another primary carbon. It's only attached to 1 other. Flanking the quaternary carbons, we have 2 secondary carbons. These carbons are only attached to 2 other carbons and 2 implied hydrogens. That makes them secondary. We can also classify functional groups according to their degree of substitution as well. When we classify a functional group according to its degree of substitution, the functional group has the same classification as the carbon to which it is attached. So whatever that carbon happens to be, however many other carbons that's attached to, that degree of substitution will be the same for its functional group as well. If we look at this bromide is attached to a carbon. This carbon is a primary carbon. This carbon is only attached to 1 other carbon. So this is a primary carbon. That makes this bromide a primary bromide as well. It's a primary bromide because the carbon to which it is attached is only attached to 1 other carbon. The carbon is primary, therefore the functional group is also primary. We could do the same for an alcohol. The degree of substitution of this alcohol is the same as the degree of substitution as its carbon. The carbon to which the alcohol is attached to 1, 2, 3 other carbons. This is a tertiary carbon. That makes this a tertiary alcohol. We can also have degree of substitution for carbocations as well. This carbocation is attached to 2 other carbons. That makes this a secondary carbocation. This is how we classify carbons and functional groups as either methyl, primary, secondary, tertiary, or quaternary. There's one exception, though, that we do need to account for, and that is the functional group amines. Amines don't follow this same system. When we look at amines, there are a couple of different kinds of amines we could have. The simplest amine would be NH3, where no carbons are attached. We could have an amine with 1 carbon attached and 2 hydrogens. We could have an amine with 2 carbons attached and 1 hydrogen. We could have an amine with 3 carbons attached. Or we could have an amine with 4 carbons attached, but then it would have a positive charge. The degree of substitution of an amine is classified by the number of other carbons the nitrogen itself is attached to. For our other functional groups, we classified the degree of substitution of the carbon, and that also was the degree of substitution of the functional group. Amines are different. We look at the number of carbons to which the nitrogen itself is attached, and that is the degree of substitution of the amine. So this amine isn't attached to any other carbons. We just call this ammonia. The name of this molecule is just ammonia. This nitrogen is only attached to 1 other carbon. This would be a primary amine. This nitrogen is attached to 2 carbons. It would be a secondary amine. This nitrogen is attached to 3. It would be a tertiary amine. And this one is attached to 4. So this would be a quaternary ammonium salt. Because it is cationic, we can't call it an amine. It's an ammonium salt. And so that quaternary one would be a quaternary ammonium salt. Most of the time, we'll be dealing with this system where we classify carbons on their functional groups based on the number of other carbons to which it is attached. Amines are the one exception where we classify it by the number of carbons to which the nitrogen is attached.
Thanks for joining us today, ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.